So this is just an orbit problem. And the idea is that in order to keep a satellite from crashing into an asteroid, it's put in orbit around the asteroid. We send satellites out to observe asteroids sometimes, and sometimes we put them in orbit. And so if the radius is 2 kilometers and the period is 3 hours, it's asking what's the mass of the asteroid. And we've done a few of these already, but just to start from scratch kind of, the sum of the forces equals the mass times the acceleration. Well, for a satellite, the only force acting is gravity. And if it's in a circular orbit, then the mass times the acceleration is mv squared over r. We can rearrange this formula and get v squared is equal to gm over r, or we can solve for the mass, and we get the mass is equal to r times v squared over g. Now, if you remember that for a circular orbit, the velocity is just the circumference divided by the period, and this is a nice way to write the velocity because they give us the radius and the period. And so if I substitute this in for v in this formula, I get this one. And it's the mass is equal to 4 pi squared r cubed over g times the period squared. And so then I just plug in for all of those things because I know all of them. It's 4 pi squared times 2 times 10 to the third meters. That's the 2 kilometers, quantity cubed, divided by g, which is 6.67 times 10 to the negative 11 newton meter squared per kilogram squared, times 3 hours times 3,600 seconds per hour, all squared. And when I do that, I get 4 times 10 to the 13th kilograms. So about 10 to the minus 11 times the mass of the Earth, something like that, a little smaller than that.